And good morning, everyone. Welcome to the AMS 50 webinar series. And today we are going to have two presentations regarding resilience in transportation system. And first, I want to introduce briefly about the mission of this committee. And the committee of AMS 50 focuses on the impacts of transportation on the economy, environment, and society. It is connected with efficient, effective, and equitable transportation systems that promote competitive advantage, economic resiliency, and sustainability for our cities, regions, and society. This committee provides a cross-cutting forum for practitioners and researchers to understand the interrelationship between transportation, economic development, and the economy, and land use, and the policies and management approaches required to create sustainable growth at national, regional, and local scales. And this committee is chaired by Professor Noreen McDonough from UNC Chapel Hill and Michael Lawrence from Jack Fawcett Associate. And if you want to know more about the activities of this committee, so please become a friend now. And in particular, you can go to my trb.org and click committee and then become friend of this committee and then find AMS 50 and then click on become a friend. So in this case, you will join us. And also a couple things about housekeeping. And first, how to raise a question. You have two ways. One way is you can type in the chat section and then I will read your question. Or you can just raise your hand virtually and then we will unmute you. So in this case, you can ask the questions directly. And also you should know, the webinar will be recorded. And so you can check our AMS 50 YouTube website later. And then here I provide you some information regarding the last webinar and the title and also the speakers and also the links to the recording. And without further ado, and then I will introduce the presentation and speakers of today. And our first presentation is about the climate change research on transportation systems, climate risks, adaptation, and planning. And the presenter is Dr. Tianni Wang. And Dr. Wang is assistant professor of Shanghai Maritime University with a PhD degree in management studies at Liverpool John Moores University in the UK. And Tianni's current research covers transportation, logistics, and supply chain management, climate change and adaptation planning. And she's the owner of the Young Researcher Prize awarded by John Prescott, the previous Deputy Prime Minister of the UK at the 2018 International Conference on Projects Logistics, and the Best Paper Prize at the 2015 International Conference of Asian Logistics Roundtable of Suba ALT Conference in Taiwan. And now the microphone is yours, Tianni.
Hello, everyone. Firstly, thank you so much for inviting me to present. Today, I would like to share my screen first. So can you see that?
Yes.
Okay. So I would like to share a topic about climate change risk on transportation system. Actually, it's based on a paper I published last year in Transportation Research Part D. And it's also a literature review about what I have researched since 2013, since I was a master's student in University of Manitoba. And after that, I have continued to do some relevance research in university in the UK. So today's presentation will be divided to the following 5 parts. So firstly, I want to do some background about this research topic. And after that, I will elaborate some the method I utilized reviewing those papers. And then I will elaborate the trades in this search area. And afterwards, because I divided those papers in different research themes, primarily six aspects. So I will explain about that. And finally, I will give you some implication and the future research direction about this research. So as you can see here, according to the report of IPCC, the climate system have been warming since the last century, and since from 2006 to 2015, the global warming is a tendency that the temperature have risen from 0.75 to 0.99 degree. That's also what we can feel, like the weathers become like hotter and hotter. And so you can also see from the damage amount of snows and ice and the sea level rise. So talking about the transportation and climate change, as what we found is that the climate change have posed a critical challenge for transport infrastructure, operation, policy making, planning, etc. So the related activities related to transportation system, including the variations in precipitation, such as the flooding, drainage, temperature like sea level rise, temperature like a high temperature or cold temperature, like high winds, thunderstorms, fog days, visibility, sea level rise, etc. Actually, as maybe some of you already know, that there are two primary methods can deal with the impact of climate change. The first one is climate mitigation. There are some examples. For example, what we have a familiar with, like using some techniques to reduce the greenhouse gas emissions. Like we promoting like green ports, etc. Another strategy is climate adaptation. It means like we use some proactive way to respond to the impact of climate change. Just let's start a research in those areas, to be honest. So the study of climate change actually is gradually moving from the purely mitigation towards to a strategy combining mitigation and adaptation together. So that's the tendency. So actually, if you look back to the papers in 2020 last year, there were quite a lot of paper doing this the areas research and combining the mitigation and adaptation as well. So here are some examples about the mitigation and adaptation measures, such as switching the road to rail, and then such as the building some forecasting systems, higher the level of the wall, building the protection wall to deal with the flooding or sea level rise issues, and, doing some like drainage and cross drainage walks, and setting up the signs on the road. And next, comes to the methodology I utilized for reviewing those papers. So we believe that we have done a comprehensive review on these topics. We select the papers related to climate change adaptation on transportation system. In particularly, we focus on road and railways, because I think shipping or port or aviation is a bit different, but road and railways is like maybe inland basis, right? So we mainly utilize the Web of Science and the Emirate Management Plus database, and we use the novel systematic literature network analysis, including systematic literature review approach and cause shape analysis. And some keywords we chose, like climate change, impact, risk, adaptation, planning, etc. So we trace back to the papers since 1970s. And then because that research was published in December 2018, so we only investigate those papers in that period. So finally, we found there's 100 peer-reviewed journal papers featured in 65 international recognized academic journals. Here, we are going to share some traits in those areas. So in overall, there was strong growing potential in terms of the quality and the publication numbers in the past decades. So as also you can see from the left corner, since 2015, there were growing trades more obviously, and 2015 was the peak with 16 papers published. And then there were 76% were published during the year from 2012 to 2018. And, as you can see from the left corner, there were top 5 journals sources, such as Transportation Research Record, Transportation Research Party, Climatic Change. So, and also we look at the geographic location, the authorship. We found that in overall North American and the European researchers are the main force in this area. However, South American, African, and Asia researchers have gradually joined the international team since 2012. And we also look at the authorship and the authorship networks. So based on the NetMiner's result, we can see there were 2 primary communities represented by the Shinosky, this group 1, and the Chapman group 2. So actually, they represented the 2 primary communities. The first one is the North American, African, Asia, the newcomers. And the group 2 was more concerned with the European area. And regarding the primary research method and themes, we found that the case studies, conceptual work was the 2 dominant methods. And also the qualitative research method make up around 76%. And there are also some studies utilize a mixed method, such as combining the modeling with case study, or using like a conceptual work with the case study, etc. And later we analyze the context. We have done the thematic analysis. And then we categorize the selected paper into the 6 dimensions in terms of different objectives of research. So regarding the 6 research themes, the first one is impact of climate change on transportation. Actually, there are quite a lot of papers investigating the impact of climate change on transportation, such as we can find that there were several weather parameters regarding the precipitation, temperature, sea level, thunderstorm, winds, visibility, and then there were different categories below the different parameters and corresponding impacts. So I will not go through too many details. So if you're interested, you can read our paper. And so regarding the impact of climate change on transportation, actually it's a difference regarding the different areas, such as for the US Europe system. They are looking at the climatic stressors, climate change impacts and adaptation cost analysis for UK road and rails. That's also what I looked at in my PhD research. Some gaps, including that, for example, in the UK, they only look at more recently. They have paid more attention about attract to the impact of climate change on transportation, and the mainly focus on the road freight. And actually, I would say in aviation, there were very few papers about climate change on transportation. And after knowing the impact of climate change, we are going to assist those risks, right? And then there are lots of tools, as you can see. For example, like the GIS, Geographic Information System, that's what we are all familiar with. And also there are others like CIA, GEM, LCC analysis. However, there are still some gaps. The first one is that the uncertain nature of climate change itself is very challenging. And also there involve some social, economic, political dimensions. It's hard to measure by numbers. There are some efficient attention on particular type of climate change events on transportation assets. And we also think that asset management is also important aspect about this topic. For example, people use some risk-based methodology and adaptation framework, asset management system, building information modeling, etc. However, regarding this aspect, there are some gaps, such as including data limitation, lack of sufficient financial resource to build the maybe asset management system. And also there's uncertain demand in the future system. And obviously we're talking about climate adaptation planning. So planning and policy is also very important aspect in this area. Some mitigation related policy about could include some like pricing, like land use or tax related policy to like maybe restrict the usage of the maybe transport mode. And some gaps include that the expected goals and capacity of policy in response to the climate change have not sufficiently translated into action. So even we have this kind of policy or planning plans, but we maybe the the operators don't know how to do based on the policy. Transportation adaptation to climate change is also a potential and a novel aspect to based on my research. So and in the past year, I think some scholars also looking at the trade-offs between the mitigation and adaptation. Maybe they establish some modeling about the benefits between them. However, on adaptation area, the research is still at an early stage. Maybe sometimes they only focus on the physical infrastructure, roadways and waterways, and look at the mid-sized case studies only, and it's only follow the top-down policy pattern. So the gaps include that existing literature is too vague or focus on general principles, or only focus on the technical measures. And so current transportation investment and planning could not address the climate change impacts adequately. I will explain that later. And regarding the adaptation tools and framework on transportation, in this table, we also summarize some tools such as blueprinting, dynamic adaptive planning, etc. and then some are local based, such as for New York City. Finally, we can come out some implication, the future research directions. So firstly, I would like to share that the barriers in climate adaptation planning on transportation system. So as we can see, the existing research is still at embryonic stage with very inadequate attention on specific transport adaptation planning, and especially in a nationwide strategy. So basically, some developed countries such as the UK or Canada, they have developed adaptation planning for maybe quite many years. But other developed countries, they are still on the way. And the lack of data in current and potential impact climate change is also a big issue. And they are also lacking of a scientific way to do the cost-benefit analysis. That is also what I'm doing in my previous papers. And then also, some people also establish adaptation tools and framework, but some of them only for other aspects such as city planning, but not designed for the transportation sector directly. And another pressing issue is that the current transportation investment planning could not address the impact adequately. That it means that some short planning circles usually is very short, like 5 to 10 years. It could not match up the infrastructure lifespan. It could be very long, like 50 years, especially with the fastened space of climate change. Maybe some assets have or the infrastructure have to redesign, and the investment benefits is hard to measure or hard to expect. That is also a big issue. So in the future, we call for a more comprehensive analysis on this topic regarding the identify the feasibility, efficiency, resilience, and also how to motivate the organization who did not have that kind of framework or measures, and also review the challenges during the climate change adaptation measures. And we also have to balance the investments in infrastructure with the planning circles, and especially within the financial constraints. And we hope there are more integrated management methods and a better cooperation between the different organizations and the stakeholders. And finally, we also promote a conception framework. It could be a standard way to do the kind of adaptation planning, such as starting from identifying climate risks in transportation system to finally prioritizing adaptation measures for climate systems. So it could be a standard way to do the research. So that is all my sharing today. Thank you so much for your listening.
And thank you, Professor Wang. And this is a very nice presentation. And the audience and panelists, if you have any questions, so please let us know. And so here, Ingo has comments. I agree that CC adaptation, CC adaptation is not as developed as mitigation, but it definitely is not in embryonic stage. I, for one, organized a workshop focused on the CC adaptation some 10 years ago, and the book is published. So we do need to do more research. Okay, so you can see here, so for the scholars who are interested in about the mitigation and the adaptation, and please refer to this link. And while the audience are thinking about the questions, and so Ingo, do you have any comments?
No, I just feel that, I 100% agree that climate change adaptation is not as developed as mitigation and should be the focus. But I think your review is focused on 2017 and earlier, right? And I think you may be missing a lot of papers done under Obama administration in the US. Yes. It was like, burst of activities on mitigation primarily, but also on adaptation. So you may be missing, under Trump administration, of course, we had a little bit of pause on climate change research, but fundamentals are there. And now we clearly see a revival of some of these activities. So, but yeah, I guess I'm looking forward to do more on climate change adaptation. It's really important area. So, yeah.
Yes, I agree. And this, I think this field is evolving. And actually, that's the reason, the Transportation Research Part D hosts a special session for the disaster resilience, adaptation, climate change. And actually, this session is edited by John Renee and also Carl Kim. And so if you have related paper, and then please submit to the TR-D for publication. And I do have a question for you, Dr. Wang. And actually, you talk about, the research is ahead of kind of the practice. So that means, even though we see some good ideas, some strategies, we develop, but actually the practitioners, they may not know how to use them. And do you have some kind of strategy, and then what we can do? So in that case, we can try to maybe educate or train the practitioners, to implement our strategies. Do you have any kind of suggestions?
To be honest, I'm not quite sure, but I think actually, to be honest, when we do some research about like on the Canadian ports or the railways in the UK, we use some like surveys or interviews to communicate with people. So I think it's also a way maybe to translate our ideas to the high level people or the operators to highlight the importance of climate change adaptation. And then maybe the high level like managers can train or their staff, I guess.
Yeah, and for our panelists, do you have any suggestions? How to transform research into practice?
I don't think I have yet, to be honest. Can I answer the previous question? Sorry. I mean about his question about the embryonic stage. Can I just explain a little bit? So actually, I think climate change adaptation, is very, has been talking about for many years. So I didn't mean that it's an embryonic stage, but I mean on the transportation area, it's not, compared to mitigation, it's not such developed. Can understand that. As you can see that, I have done the research by 2018. There were quite a lot of paper published later, especially I mentioned in 2020, because I'm still doing the literature review right now. So I can see that there were quite a lot of papers are published published last year. So it have changed a little bit, I guess.
Okay, and also I think maybe, for example, as a professor, and then we can introduce more of the topic into our lecture. So in that case, because we are training the next generation of practitioners, so in that case, they have the sense, and then they know the reference, and then they can think about how to use those approaches in their daily practice. And also we can have, say, this kind of workshop. So in that case, we can give more information to the DOT, and then also the regional transportation agency governments. So in that case, they can, be more aware of different approaches and then the strategies to address the climate change issue. But anyway, I think, you have done a great work, and we know it's evolving, and then hopefully, in the next 5 or 10 years, you can come up with a different, a review and to see what's the new progress for the last 10 or something years. Okay, thank you very much, and Dr. Wang. And now I'm going to switch gear and then change to the second presentation. And the first one, we see the climate change is a big issue, and actually how important it is, right? So what's the impacts? And our second presentation is lack of resilience in transportation networks, economic implications. And then we have two great speakers on this talk. And the first is Dr. Igor Linkov, and he is a senior science and technology manager with the U.S. Army Engineering Research and Development Center, adjunct professor of Carnegie Mellon University, and he's responsible for ERDC's project portfolio in the area of crisis management and resilience. He develops answers and tools for measuring risk and resilience in interconnected network and applies these tools to critical infrastructure, transportation, energy, and cyber system, supply chains, and currently manage response and recovery following the COVID pandemic. Dr. Linkov is elected fellow with the American Association for the Advancement of Science and Society for Risk Analysis. And the second speaker is his colleague, Margaret Kurz, and she is a research environmental engineer with the Risk and Decision Science team at the U.S. Army Engineering Research and Development Center. She applies masters of operations research, system engineering, decision science, and risk assessment to traditional and emerging management problems. She is advancing answers and metrics for resilience codification for a variety of systems and skills. Margaret has a Master of Science in Engineering from Tufts University and a Bachelor of Science from Cornell University. Welcome, Ingo and Margaret.
Thank you very much. Do you see my screen okay?
Yes, no problem.
Okay, perfect. So first of all, a little bit about my organization. We are research arm of Army Corps of Engineers. We have over 2,000 people, significant budget. We spread across multiple labs. The team we represent, Risk and Decision Science team, is in Boston. And even though we are part of military, we are to a large extent civilian organization, and we deal with multiple issues related to crisis management, including climate change and things like that. So what I'm going to build on is actually our experience dealing with COVID crisis and impact of transportation and supply chain. But Margaret will present a case study when we quantify resilience specifically to transportation network. And I guess the message is that we really need to do more on risk-based and resilience-based approaches in the context of transportation, including, as the first speaker mentioned, climate change adaptation, because resilience is adaptation measure. It's ability to really ensure our well-being during changes, and some of them are inevitable. So experience that I like to start with is actually what we did working in COVID response as a part of FEMA, Health and Human Services Army Corps team starting like March last year, and we're still working now. We essentially provide data analytics for most of the COVID-related decisions in our region, which includes 6 states and New England. What I like to start with is that each state is unique. It's unique from point of view of how COVID get manifested and how population respond. So, for example, Maine and Massachusetts are very close to each other. And Maine didn't have this first peak, but then they had significant second wave, while Massachusetts was really affected by first wave. But economically, what is interesting is, since this is economic group, is that Massachusetts recovered quite nicely but Maine was disproportionately affected economically. So it's clear that Maine is, as a state, is less resilient than in Massachusetts. And it's interesting to observe difference in how policy and economic impact correlates. And this is actually, back to your question, Professor Gao, the reason we need science in government and the way to influence government and practice is through bringing these issues up when, just political will not necessarily translate in appropriate behavior. So, for example, you can see that, we had significant cases in New York and Michigan, and, it correlated with closure and lockdowns and less, but you can see in other states, it's other way around. They were locked down and economic activity was paralyzed when actually the caseload was not as high. So this correlation of different measures is really important. And if you look at what is the core of this presentation, is time spent in transit versus time in different states, you can see a quite significant difference, right? Some states, and we are talking about last summer, some states recover pre-pandemic travel, while others were significantly depressed, like Pennsylvania, you can see Rhode Island. So there are differences, and many of this difference has fundamental roots in resilience, right? Another issue that we have now related to transportation is actually supply chain disruptions. It's difficult to believe that, in the US we have disruptions in food, all right? We don't have enough chicken, we don't have enough ketchup. I can probably understand that we don't have enough chips for computers, but food, that was really shocking. And it's visualized here. Again, this is for New England. You can see that nutritional deficiency in New England state was significantly impaired during pandemic, and it's still not back to pre-pandemic level. Right, and it's especially true for remote location where transportation is the key. So we have this beautiful island, Martha Vineyard, and this is actually where Obamas and Clintons have their summer houses. So you would think that they can figure out food supply chain, but apparently not. You can see that in this island, the food shortages are quite prominent, and this is like visualization that you can see through monthly pantry visits. And the reason for that is that you only can get there with ferry. And by the way, this ferry was recently affected by cyber ransomware attacks, and their cyber networks were paralyzed. They were unable to make reservation to the ferry for like almost a week. So that's, I think, a long way to really show that transportation network are crucial in supply chain and pandemic response, and we need to do more. We need to do more even for vaccine failures. Again, supply chain was very crucial in failure of vaccines. And well, since we have economists here, the question is like how you deal with this, right? So the favorite way for economic intervention is just dump more money on the communities. But again, because of the difficulties in these remote communities, we show that loan penetration for food services is not actually helping remote remote communities. This work we've done for Small Business Administration, it clearly shows that financial support is really working in areas where infrastructure is well developed, but when you go to remote areas where the needs are important, they are not really responding that well. So why is it happening? Well, what we study in our team and our line of work is actually a complex system and their susceptibility to threats, whether it's climate change or COVID or anything else. And the message that I like you to have today is that resilience is a really important component of that. As previous speaker noticed, it's impossible to do risk assessment for unknown threats, and resilience is the way forward. Even in previous presentation, I noticed that there is a great deal of confusion between risk and resilience, right? So risk is, and this is from Oxford Dictionary, risk is a situation involving threats acting on system vulnerability resulting in damage. So risk start with external stressors acting on vulnerable component of your system. And the goal of risk assessment is really not to let system functionality go down. If you manage risk successfully, you achieve state of security. System operates free from danger or threat, either because threat is removed or because system is hardened and it's not vulnerable, right? But resilience is a very different concept. Resilience actually starts when system is already, functionality is already down. And ability is defined as the capacity to recover quickly from difficulties. So the problem is that resilience and risk are often confused, and moreover, they kind of the terminology is misused in the concert with other in the concept of system affected by threats. So we have many other concepts like agility, adaptability, resistance, robustness, sustainability, and all of them have different meaning. And resilience is very special. It's just ability to recover. And the problem in the field is that resilience and risk are often confused. Like this is from Obama's definition and executive orders. You can see that you have component related to resilience, adapt and recover, but withstand, respond is really what is essence of field of risk analysis. And in the context of pandemic response, way before this current pandemics, we study how resilience and risk manifested in epidemic spread. This work was done on kind of tail end of Ebola pandemic, or actually it was epidemic rather, back in 6 or 7 years ago, and we show that even though restrictions like travel restrictions or adding fear to population always reduce risk, no matter how small pandemic or epidemic is, resilience is actually also reduced. So there is an optimal when you have ability to deal with pandemics, but not reduce resilience to the extent that it will be very difficult to recover. So and this was the problem. This kind of line of reasoning and line of work was not developed in time for COVID pandemic. And initial measures related to resilience thinking were done in ad hoc manner without really clear idea what is the optimal from point of view of size of pandemic and ability to recover. So what we are working on now is looking at the way to deal with resilience by designing system to be resilient or by having enough stockpile of resources to intervene, right? So in resilience by design, we build systems that it can recover on itself. In resilience by intervention, we have external components that would allow a system to recover. And this way of thinking is actually getting integrated in many areas now in more formal response to failures and future preparation. Another important area that actually Margaret will tell more about is resilience and efficiency. One of the problems is that our network, including transportation network, are designed to be efficient and not necessarily resilient. And Margaret will talk more about that. This kind of illustration. So efficiency for road network is just ability to reduce time people spend in traffic, while resilience is actually ability to recover for unknown disruptive events like major accident or snowstorm or things like that. So how you quantify resilience? Well, I skip what we call resilience matrix. It's a way to use metrics-based approaches. I think we're running out of time, but we published it extensively. And I will let Margaret talk about more network resilience and economic impact of lacking resilience. And the idea here is that we represent infrastructure networks, including transportation networks, as links and nodes connected, and resilience is property of the network structure and properties of links and nodes. Right. So, Margaret, I think you are next. I will do your slides.
Thanks, Igor. I'll let you know when to advance. So, good morning, everyone, or good evening, wherever you are. My name is Margaret Kurth. I'm going to tell you about some research that we did a couple of years ago in collaboration with a company called Regional Economic Modeling Incorporated. And we did this to advance a methodological approach for resilience planning. We paired road network resilience quantification with regional economic modeling in order to put resilience science to use, to build a business case for investing in resilience, and also to help establish a process for doing resilience-based planning. Here are two papers that form the basis of that work. Next slide. So just very briefly, the foundation of this work is a set of road network models that we built so that we could analyze a wide range of disruption scenarios. This was done by a colleague, Gannon et al. They built models for many US cities, I think, maybe at least 20 US cities. And those allow us to calculate the average annualized travel time for a peak hours commuter. Once we get the network established and working, then we have a system that we can break, essentially, and see what are the different impacts. Next slide. Here are different disruption scenarios that have been modeled with those networks. The one that I'll focus in on here is case 2, random disruptions. And so with this sort of scenario, the networks were incrementally disrupted, increasing initially 5%, but then we dropped down to 1%. 1% of all links could be disrupted, and then subsequently another 1%. And disrupted essentially means that we slowed the travel speed down to 1 mile per hour. And then looked to see how much delay occurred in the average traveler. Next slide. And so this is some of the results of that study. And here you can see that as you incrementally increase the percent of the road links that are disrupted, you increase the amount of delay that commuters are experiencing. Here, this is for about 8 different US cities. And you can see that they're not all experiencing delay in the same or disruption in the same way. Different cities, for example, San Francisco is this top line. And you can see that 5% of road networks disrupted in San Francisco will increase delay above your normal kind of commuter delay by 50%. Next slide, please. Igor mentioned this already, but generally we see road networks as being managed primarily for efficiency. For example, you add an additional bridge or you add additional lanes and look to increase your efficiency in travel time. And we would like to kind of flip the thinking a little bit to also consider how do you decrease the recovery time from disruptions. Next slide. So like I mentioned, we partnered with Regional Economic Modeling Incorporated, and this is kind of the workflow that we used. Normally down here in your red box, you you use transportation models to see how much you can improve along these different types of metrics, vehicle miles traveled, vehicle hours traveled, and trips. And those things can be fed into an economic model that's maintained by REMI to see how will that impact these various kinds of parameters, how much people are spending on fuel, how much different industries are impacted by how they get their goods to market, etc. And so you can translate basically your road network efficiency into economic output such as GDP. Next slide. Oh, sorry, efficiency. And so we've kind of repurposed this model basically in collaboration with them to look at what if you're not using improvements in efficiency, what if you are looking at what happens when you have transportation delays. We tested out two different types of delays. One in which the transportation cost increases are equal to the percent disruption. So 1% disruption equals 1% increase in transportation cost. And we also looked at the results of the Gannon et al. Model, which was the random network disruptions. So you have 1% disruption, but you may have had, say, a 7% increase in delay. And so we tested all those things out in an incremental way for 10 different cities. Next slide. Here, these are what we're calling efficiency-based delays. 1% delay or 1% disruption is 1% transportation cost increase. Here are the results of that. And then we'll juxtapose that to the next slide, please, to show here's what's happening when we don't use that proportionality in the disruption and the cost. Instead, we're using the delay. Next slide. This is both types of results put against each other. And so the colored bars are the efficiency-based delays. The transparent bars, I hope you can see them clearly, are the ones that are related to the delays. And you can see that there's a really big difference here, that you have to be considering how people are still able to get around or not able to get around when the road networks are disrupted. And we're talking about, relatively low levels of disruption, not, an earthquake taking out in an entire city of mobility. Next slide. We also looked at the recovery of GDP in subsequent years, although it's not very granular, but just to show that this 1% GDP, for example, of San Francisco is very substantial. So this justifies us looking at resilience interventions into our transportation networks as well as efficiency in order to keep economies going. I think that's all for me. Thank you.
Igor, you want to unmute yourself.
Can you hear me now?
Yes.
And do you still see my slides? Yeah, okay. So just to summarize, so Margaret showed that we need to integrate economic model and resilience model. Otherwise, you may be off. Economic models are very linear and proportional. Resilience often is non-linear. Right. So just kind of a bigger picture, we look at these issues related to pandemics, and we clearly saw that what Venetians did 700 years ago with Black Plague, they actually changed network structures through local intervention at individual levels, through protective clause, through building lazaretto islands at community level, and through regional trade. And this resilience, acting on resilience, is absolutely essential in getting out of economic crises and like what we see now, and building future infrastructure. So in the world of resilience, we're talking about panarchy, where society kind of goes through crisis, like after Black Death 700 years ago, we had Renaissance. So you have up and down periods. But what we argue that we don't need to have to sort of population die in plague to have Renaissance. We can move to better system structure just using analytical tools. And I think this is how we see getting out of current pandemics. We really need to think about how to deal with resilience, and especially in the economic side. I have been working with OECD on economic aspect of resilience, but overall vision that we're promoting is that real world needs to be visualized as interconnected networks, and we need to use network science to assess management alternatives and find the one that improve resilience and efficiency and reduce risk in our system. And currently, overemphasis of resilience, of efficiency, results in supply chain disruption and other failures that we see happening over COVID crisis, including financial system shocks. So again, the future is kind of harmonizing efficiency and resilience in our systems. And we published a lot. We'll be glad to share. And this book is just out on COVID, systemic risk and resilience. And for those of you who are interested in climate change adaptation, I organized a couple of workshops specifically on that topic back 10 years ago. We'll be glad to share as well. Thank you very much. We'll be glad to answer questions.
Okay, thank you very much, Igor and Margaret. And while others are thinking about the questions, and John, maybe you can unmute yourself and then bring about your previous question here.
Yes, thank you. I enjoyed all the presentations. And for those of you that don't know, I'm one of the co-editors of the Disasters and Resilience section for Transportation Research Part D, which Jason is the co-editor-in-chief on. And so definitely encourage you all to submit your submissions to the journal. And the work I've been doing, I've been starting to really see a difference in the way that planners and engineers think about these particular issues. I work closely with engineers. I'm a planner. And, a lot of the times planners are very focused on the distant future, climate change, and how do we set targets to reduce the carbon emissions, to meet, the different climate change targets, set forth by, like the Paris Agreement, things of that nature. And we think, we often think as planners, how do we work backwards from a long-term distant future target into the present? How do we shift modes? How do we encourage more sustainable travel? How do we encourage more sustainable land settlement patterns to support those types of goals? And I've been noticing, and you see this present, in a lot of state goals, even at like DOT's level. But then I see because I also serve on the Florida Advisory Committee for our long-range transportation plan. And I see at the ground up level, the day-to-day operational level, the discussion is very much, it's hard to take that distant, vision from the future to the present, and then to think of how does that impact practice? It's much easier from a practical standpoint, if you're an engineer, to talk about the adaptation, to existing infrastructure, right? But I think the pandemic has given us the opportunity to really radically think about different ways in which people travel, and the fact that maybe travel reduction is more possible now than we ever thought, could be in the past. But again, at the DOT level or a transportation agency level, how do we rectify these different views from the planning and the engineering world? That would be my question.
It's an excellent question. And I started in risk analysis some 25 years ago, and I kind of started looking at transportation only some 10 years ago. And I was shocked to see how little this kind of risk culture penetrates DOT world. And I 100% agree with you that at practice, transportation regulators are really lagging behind other infrastructure, even though that, transportation like seatbelts was kind of early example of risk assessment successes and made career for many people. I really don't know how to help in that. And I really tried, but even talking with my colleague at Volpe Center here, it's uphill battle because, again, off the record, the state of application of risk assessment in transportation is what we have in infrastructure 10 years ago. You're just getting through like early embracement of this. Like I was recently on a brainstorming call on how to do risk assessment for train derailment, right? Well, it's impossible. Sorry, it's like one of this pandemic type of event that you can fix like major issue that you see in daily life, but it will be happening again. So you really need to think differently about the whole issue, right? So the only thing I can say is that maybe, and I'm in federal government, maybe as a part of federal family, we can internally somehow work across different agencies and with help of more forward-looking people like you, John, attract attention to this evolving science of emerging risk and what is doable, what is not doable. So I really hope that we can make a breakthrough, and pandemics, unfortunately, with all the losses, the good thing about it is, just as you said, it shows that you can really do out-of-box thinking and try something completely new and different.
And thank you very much, John and Igor. And in the question part, I see Professor Zhenhua Chen raised a question. And can you please elaborate how the transport network resilience was incorporated into the economic modeling framework? In addition, how could the result be validated? So Margaret, and can you just talk to Professor Chen and answer the question?
Hi, sure, yes. Actually, I was just typing out my response to Professor Cheng. And I shared the paper with them, but I'll put it also into the chat. But right, we had to make some assumptions about how transportation cost increases so that we could see how different scenarios affect the regional economies. There's two scenarios, one in which we just do a simple 1% through 5% increase in transportation cost. And the other one, instead of making it equal to disruption, we make it equal to delay. So if you have 20% additional delay, we say that's 20% additional transportation cost, for example, with different disruption scenarios, different cities. So it's all different levels. That's elaborated on in the paper though, so I'll share that. In terms of validation, I would say this is purely predictive. The regional economic models are documented and used already, in the private sector and used by city planners. But this is a bit more of a thought experiment. So we don't have a validation, that we can go out and measure, for example, how much transportation costs actually increased when we disrupted 1% of road networks. Thank you.
I'd just like to add that it's impossible to validate economic models. That's my problem with economists. They use like very simple assumptions, many parameters, like thousands of them, but validation is impossible. So it's really unique field that has so much influence with such a, simple modeling approaches. And working with OECD, actually, we really try to change that mentality. Economy is a complex system and needs to be considered appropriately.
Okay, and here I see another question by Michael Lawrence. And did you try to explain the different impacts across cities? And did you look at different network links and compare impacts?
Margaret, do you like to take it or do you like me to respond?
Hi, again. I'm just trying to see the question. So we do have some speculation about why cities are different. Igor likes to use the example of Providence, Rhode Island, that it's actually a very efficient network, but it's not resilient because there's not redundant links. We think redundancy is really important in this model for how vehicles can reroute. It may be the main mechanism really in the physical network for maintaining resilience. And so, you could look to other cities that have many more redundancies. We do elaborate more on that in both of the papers, the one that focuses just on the transportation networks and also on the economics. We don't have that much insight into the actual economic differences between the cities. So it's a little bit, they're simple conclusions there, but you'll see in the paper, I just posted the link. Thanks.
I'd like to add, we compare 40 cities in the US from point of view of efficiency and resilience of transportation network. You can see that comparison. With economic side of that, we have individual models for the cities, but unfortunately, this line of work is not popular with economists and transportation economists specifically. So if anybody is interested, we would love to do it for real. That was kind of just exercise to show capability of the methodology. And result are kind of shocking how much difference you will get if you consider resilience.
Okay, and actually, we have two more questions, and then I'm not sure the speakers, and do you still have another 5 or 10 minutes to stay here?
Sure. Yeah,
okay.
I can.
Okay, thank you very much. And you can see the question is, from Baby, and his question is, may I ask if is there any theory to support resilience study on transportation infrastructure?
I'm not sure I understand the question. Can you say it again?
May I ask if there is any theory to support the resilience study on transportation infrastructure?
Margaret, can you answer?
About the theory?
Yeah.
Well, the theory of resilience, yeah. Go ahead, Igor.
Yeah, no, we have a book on science and practice of resilience. It actually at least present our thoughts on resilience as a complex, it's actually present fundamentals of resilience as network property of the system. And we approach it from complex system point of view. So that's probably a good summary of our vision. Resilience as the field has not developed in a fundamental way like risk analysis, right? Risk analysis is developed in all fields: financial, health, infrastructure, transportation. We know that risk is threat, vulnerability, consequences in some shape and form. Resilience has very different meaning for ecologists, like they use the spanarchy ideas. Psychologists, you are talking about individual resilience, like how you deal with stress. Economists, they have different views. So in all these different disciplines, you have different school of thoughts. And I think we are first trying to reconcile that. We have papers on financial resilience, on psychological resilience, gerontology, infrastructure, transportation, cyber, you name it. So I suggest that you can look at our book. I think that's the best I can recommend. Over.
So any additions from the other two speakers? And if not, here we have another question is to Margaret. How did you distribute the increase in transport cost among the industry sectors in each of the cities you studied?
Well, thanks for that question. I don't have a very satisfactory answer, I'm afraid, because we're using the regional economic modeling incorporated models. And we don't have leverage over how the transportation costs might be distributed among the sectors. Our advancement here really is just translating how delays are modeled and then feed them into the economic models. We don't have levers and knobs that we can manipulate within that. Those models are documented, and you can look up Transite, and you can also just look up REMI to see them, but they're more complicated than I could describe to you. Thanks.
And thank you very much, Margaret and Igor. And then you see our committee chair, Michael Lawrence, send you a note, regarding if you have a research topic to the committee, and then we would be happy to publicize it with the federal funding sources. And also he offered his email. And so if you have an idea, please feel free to talk to him. And so thank you very much, all three speakers. You have made wonderful presentations, also, very nice discussion among the speakers and the audience. And thank you very much. And also, I want to remind all the audience, we are planning for our next webinar. And the next webinar is about enhancing shared mobility with machine learning, and it's going to be sometime in August. And so I will look forward to see you in August. Thank you very much, everybody. I will see you.
Bye.
Thank you.
Thank you so much,
everyone.
Good to meet you.
Thank you very much.